What is the inverse procedure of a given procedure f? Well, let's seek inspiration from the previous example that we saw. So, what we had was the function f, which assigns alpha, beta, gamma, and delta to the numbers 1, 2, 3, and 4, like this. So you just draw the arrows, and those arrows define the function. Now, by flipping the arrows, what we got was the inverse function, alpha, beta, gamma, and delta, with domain 1, 2, 3, and 4. And the assignment, well, you just reverse the arrows, like this, and this is f minus 1. Now, from this thing, let's try to evaluate what is f minus 1 of 1. Well, if we have this diagram, it's easy. You just follow the arrow. This is the input 1. You just follow the arrow, and you get delta. Okay? So this is just a simple evaluation of a function. It just turns out that a function is special. It's the inverse function with respect to the original function, f. So, but besides that, it's just a normal evaluation. Okay? Let us now think about the following situation. Imagine that we did not have this diagram. So this thing did not exist. So this does not exist. And so how are we going to make this evaluation? F of 1. F in the inverse at 1. Well, one way to go about it, well, just think about it. What we are looking for is, well, if you fix 1 here, what is the x, the input, that is assigned to this 1? Okay? In other words, what we have before us is the following question. F of x is equal to 1. What is the x that solves this thing? Well, the answer, well, you fix this thing, and the answer should be f minus 1 of 1, the inverse, evaluated at 1. So in order to solve this thing, well, I'm going to give you a 3-step recipe, which, by the way, you can use for many other equations, not just this one. But let's write it out. The first step is to analyze. You analyze what? You analyze this thing, the equation f of x is equal to 1. The second step is to guess. You guess x. What x do you think solves this thing? Well, and because you are guessing, the third stage is to simply verify. You verify whether your guess is any good. Wow! By substituting your guess into that equation and seeing whether this thing, which you can evaluate because you have f, whether this thing is the same thing as this thing. So when the two sides of the equation are equal, well, the statement is true, and so you have a good guess. Let's now use this thing, these 3 steps, to solve our equation here. So let me write it like this. So step number 1, you just look at this thing. Well, we know f, and by looking at f, we notice something. Well, you not only have the arrows that tells the assignment, we fix this thing, our target. We notice that we have a small domain, just 4 elements. And with this information, now we go to the step 2. You try to guess. And because the domain is quite small, well, let's just choose every possibility. Okay? So let's try each one. X is equal to alpha. That means that, of course, this is our guess. So and then you verify, okay? So let me put here the third stage, 3. Now you verify if your guess of alpha is any good. Well, is f of alpha is equal to 1? Well, f of alpha is 2. So you get this thing is equivalent to 2 is equal to 1. And obviously this is a false statement. Okay? So our guess was not good. So, if your guess is not good, you just repeat the process. You analyze and you guess again. So, because you have a small domain, let's try the next one. X is equal to beta. You have f of beta is equal to 1. Well, it's not true because beta is 3. So you get 3 is equal to 1, which is again false. The same thing will happen for gamma. Is again, gamma is equal to 4, so you get 4 is equal to 1, which is again false. And finally, when you choose x is equal to delta, you get here the 1, and 1 is equal to 1, and this is true. Okay? This is true. From this thing, now, we can write finally that f of delta is equal to 1, or in other words, f minus 1 of 1 is equal to delta. Okay? By following these 3 steps, you can find what is that evaluation that we had that we started with. Okay? It's here. This is very important because contained in these things is a very important idea that evaluating inverses, the idea is this: evaluating inverses is connected with solving equations. In fact, we already have seen this in the properties of inverses in the previous video. Recall that we saw this property: f of f minus 1 of y is equal to y for all y in the range big Y. Okay, we saw that previously. But you see, that means that for every y that you choose here, what this equation is telling you is that this thing here, see it as a unique symbol for a variable. This thing here is the solution of this equation, f something is equal to y. That thing here, you see? The x is in fact this block here. And the solution x is equal to delta is what we set to be f minus 1 of 1. Okay? This is very important because this is already telling you what you have to do to find f minus 1 of y at a specific y that you chose. You just solve the equation here, thinking this thing as unique symbol for that unknown. So the unknown is here, the box. This gives us a way to find the inverse function. Okay, following this recipe, notice these things. Okay, you have a way now to find for every function an inverse function. And now let's formalize this thing into a definition on the next video.